Okay, hi guys. Another update about the switch mode power supply in case any of you are interested. Some of you may be just, again, but oh well. As you told me a million times already, that it's in my channel, so I should be like, I want to make a video, I make a video, and it's up to you whether to watch it or not. And I fully agree with that, it makes perfect sense to me. If I see a video from a YouTuber I like, and that video just does not attract me, I just don't watch it. Why just go there, watch the videos that you don't like and bitch in the comments? Makes no sense. Save your time and watch the video you like. So this right now is another step forward to making this thing into the complete power supply. The problem, as you may have seen in my another videos about in previous parts of this series, I was using my bench power supply, that bastard there, to power the control circuit. And why did I do that? Well, that's because it's tl494. And it does not have a micropower startup. And to make things worse, it is located on the secondary side. It is galvanically connected to the output of your switch mode power supply. So in order to supply power for the controller there, you have two ways really. You can use an auxiliary power supply, just like a little flyback like this. Disadvantage of that approach: complexity, and it takes the board space. This approach is used in the ATX power supplies because they Type ATX motherboards require 5V standby rail, which will be on present at all times, even when the PC is off. And there is another approach, that is to make the half-bridge, which is normally controlled by the tl494, make it self-oscillating, so it has a tendency to oscillate on itself. It may sound kinda bizarre and pointless, but bear with me. Basically, the approach which makes this half-bridge self-oscillating was used in AT power supplies, and they proven itself reliable. They were working just fine, so I decided to go and copy some of the circuitry from the AT power supply. Unfortunately, you may remember that previously I used the MOSFETs as a switches there, but I could not make that MOSFET half-bridge oscillate with a simple feedback circuit. I tried, I spent 2 hours, I decided it's just ain't gonna work for now, so I just went and used BGTs there, MG13009s. The circuit on the output of this drive transformer did not change much. You may remember that I just had a 10 ohm resistor in series with the gate. Well, I do have the same here, 10 ohm resistor with the series in the base now. And one thing I added is a little diode there, which will conduct the negative half cycle, so there won't be a reverse voltage applied to the base emitter junction of the transistor, which may kill it. Alright, so in type AT power supplies they used more sophisticated circuit in the base circuits here on the output of the drive transformer. So they set up the initial start pulse to kick this half-bridge into running, self-oscillating, they use the resistor between collector base on both transistors, and whatever transistor turns on first, obviously turned on first, produced a pulse, and then the feedback took the care of the rest. And also I did change some turns in the drive transformer. Now the gate windings consisted of 20 turns each. The base windings now consist of 6 turns each, because I don't need that much voltage anymore. 6 turns in the bases. And I also, in order to add a feedback to the system, I also added this little winding, one lead of which is this one, another is this one. One lead is connected to the half-bridge, to the emitter of the top transistor there. Another lead is connected to the right over here actually, to the transformer. So that winding is in series with the primary of this transformer, and it works that way. To prove that it is indeed a self-oscillating scene, I'm gonna go and just unhook the drive transformer from the breadboard completely, as you can see, and just so it is bloody obvious, as you can see, not connected at all. Again, in type AT power supplies they use more sophisticated circuit in the bases, so it was running on itself. It could start on itself, but here, due to this simplicity that I have just 10 ohm resistors there, I need a bit trickier way. I need a quite large pulse to get it going, so that's what this capacitor resistor is for. Let me demonstrate. It's plugged in right now, and you can see it doesn't do squat, but it just takes me to brush this alligator clip on that capacitor, and you will see that it will spring into action. Notice how bright the bulbs are, because they are receiving 28 volts, 2 in series. And I can also go and short out the primary of the drive transformer to demonstrate that the control circuit, once it has power that will be bootstrapped from the output of the supply, that it will be able to control the oscillation there. I'm just gonna go and touch these two wires, and you can see it just stops. Now let me discharge the capacitor first. There and there. Now let me connect that board back, and you will see that it works just fine. Okay, board is connected. Right now I'm gonna go and just pull out one resistor, this 33 ohm one. So right now the circuit, the tl494 is not receiving power, so it will start up just fine as is, and it will run free, oscillating freely like you saw it a few seconds ago. Let me do the same procedure. So it runs. You have the voltage there, which is on the output. If I'm gonna go plug in that resistor now, you will see it drop. See? Just killed it. Oh well, let's restart it then. See, it's running, and the voltage is obviously now lower because it's regulating. So that's a progress so far. I won't upload any schematics yet, because as you saw, I did some major changes to the circuit. It's not using MOSFETs as switches anymore, so yeah, it doesn't make sense to make the schematic now, because I'm not sure whether or not I'm gonna use this as a final version. For all I know, I may actually use something else. again. And one more thing I wanna try is I wanna just go connect it like that, and it should actually start up on itself now. And it does. Look at that. Now I don't need to brush it. Awesome. To make it fully reliable, one thing you should do if you're gonna do it this way is to put a high value resistor here. High value because you don't want excessive current flowing through that resistor. You just want that resistor to discharge this capacitor. Because once the capacitor is charged, it will no longer let that pulse of current flow through it and start and turn on this transistor, which will switch the thing on. So that's that so far. Thanks for watching. See ya.